Oftentimes when I hear people talk about plastic, they talk about them generically and generally, like they're all one thing. But actually, there are a lot of different kinds of plastics, and each one of them has to be treated differently. We select those materials because of those different properties, and because each of those properties can give us a different result. Take, for example, this water bottle. The bulk of this bottle is made out of a material called PET. And it was selected because it's a clear material, which is very nice for this sort of application. It also has fairly good impact strength, and that's critical for any kind of application containing liquids. It has good oxygen barrier and vapor barrier parameters, and that's very important for any kind of product that contains food that prevents spoilage. And perhaps most importantly, this material is fairly easy to work with, which makes it pretty cost effective. Now, being cost effective is really important. If this container cost $1,000, it wouldn't make any sense for you to buy it just to get $1 worth of product out of it. Always remember, if the economics don't work, there's no sense in making the product in the first place. Now, this lid is made out of different materials because different properties are required of it. First off, it has female threads in there, and that's pretty difficult to make in a lot of materials because of the complexity of the tooling that's required. So this has to be stripped off of the core inside of the mold, and that doesn't work so good for PET. But it does work pretty well for this material. This is HDPE, or high density polyethylene. We generally just call this polyethylene. Now, another great parameter of polyethylene is that it's lubricious. It's a word of the day, so feel free to use that in a sentence. It means it has an internally lubricating property to it. So that's nice when you go to pull the threads off. And another great parameter is it makes a pretty good seal. Not a great seal, but a pretty decent seal. Now, because in this application we're trying to seal a polyethylene lid against a PET bottle, you've got a couple different choices. You could use an elastomeric seal, kind of like this one. So inside of here, I don't know if you can see that very well, but there's actually two different materials in this lid. Right? So this squishier inside is an elastomeric seal. And that's one way to do it. That's actually a really great way to do it. Your chances of preventing leaks is much higher using this method. But the problem is that you've got two different incompatible materials here. That makes it harder for recycling. So if you want to go with the easier to recycle method, you're stuck with one material. And what that means is this is harder to make. It's a more precision product, and it means it's more expensive. So collectively, in this scenario, we end up with a PET bottle. This label is nowadays is PET, but that's fairly new. It used to be made out of different materials. And then you have your polyethylene lid. So in this container alone, you have 2 to 3, depending, different materials that you're using. And that makes it really difficult to recycle because those different materials are not compatible with one another in a melted form. So if you were to just throw this into a grinder and grind it up into its little bits, you have little bits of mixed material, and you can't process that. It's effectively just trash. And the problems don't just stop there. There are a lot of other materials out there, each with their varying degrees of incompatibility. Now, take for example this guy here. This is a PVC material, and if you've ever had to crawl under your kitchen sink, you've probably seen some of the piping made out of this material. It's fairly easy to work with, and of course that makes it cost effective. Now this is also PVC. It's very different though. As you can see, this is quite flexible and it's clear as opposed to this material. Now what makes these different is the additives that go inside of it. You see, no plastic is just a plastic. They tend to be more of an alloy, and different chemicals are added to that material to create their unique properties. Case in point. Now what makes this flexible is a material type called a plasticizer. I don't know if you remember, but a few years back there was this big scare about a material called BPA that was inside of a bunch of different more permanent water bottles. There was BPA free, and you still see that on water bottles today. Well, BPA is a plasticizer. It's one of the things that changes the parameters of a material from this to this. So when you're trying to achieve different results, you add chemicals and you get your different results. But that also means you end up with a lot of different varieties of material. For example, with polypropylene, there's actually about 1,600 different grades of polypropylene, all of them having various nuances that make them appropriate for this application or that application. And even without all these sub-varieties of materials, you still end up with an awful lot of different materials. Now take, for example, this material. Now, this is a unique material. It's called acetyl or acetal, depending on where you're from in the country. Apparently there's a regional dialect thing to it. DuPont makes this product and they call it Delrin. So I'm just going to refer to it as Delrin. But one of the nice things about Delrin is it springs back very nicely, and we've actually managed to make a spring out of this material. You don't see a lot of springs in the plastic world, but this is one of them. Very, very clever application on this guy. Anyway, if you take these two materials and you chop them up, mix them together, and apply heat, you get a very toxic outgassing of chlorine gas. That's that gas that was used in World War I in trench warfare and is now even illegal in war. Yeah, that material. That can come from the combination of these two chemistries coming together. So it's really important to understand that you can't just mix things together that you don't know very much about and expect all to go well. Sometimes there's some real consequences from it. And like I've said before, these things are not unique to plastics. You'll see a lot of chemical incompatibilities out in the world, magnesium, water, chemistries that are under your sink for cleaning. These things don't all play together well. So when you're talking about recycling of materials, it's actually a very complicated thing to do. A lot of times it's best to just kick that upstream to the supply chain and let the manufacturers deal with these problems, because in that context, they're already separated. There are a lot of products like this floating out in the world begging to be reclaimed. Sad reality to that is we don't really have the methodologies for doing it properly today. So today the situation is a little bit bleak. A lot of people who are recycling in this country really have to close their eyes and not look very deep into it to pretend that it's actually helping the world. Now, in an effort to be more green, a lot of people have secondary recycling bins at their curbside, and they'll throw materials like this into them. But unfortunately, we don't really have the facilities in America to process them very well. Recycling is a type of manufacturing, and over the last 30 years, we've lost a lot of our manufacturing capabilities. So unfortunately, what that means is materials like this get collected from all over the city and brought to a packaging facility. They're bundled together in bales, and then they're shipped to processing facilities throughout the country. Unfortunately, there's a lot more materials coming into those facilities than they have the ability to manufacture. So unfortunately, what happens a lot of times is these bales get put onto a ship and shipped overseas. Our government tends to pay other countries to take our trash. And then we add thousands and thousands of gallons to this existing problem just to ship it overseas. And of course, that doesn't resolve the problem that it's still expensive to manufacture to turn these into usable materials again. So a lot of these countries just light these materials on fire and let them burn. And if you've got materials like this involved in that, you have some pretty nasty chemicals coming off of that. Look, the bottom line is there are a lot of things that need to be resolved here. But plastic itself is not the problem. There's a lot of processing that's going on that could be done a lot better. So what's really required is that people like you understand how this whole thing works. And together, we can make things better. Well, that's all I've got for you today. But make sure you come back and check out the channel later because we're working on some really cool things. Don't forget to like and subscribe so you can get all our latest content. And remember, go out there and do something cool today.